Hello, dear colleagues. My name is Liana Akapyan, and I'm a researcher of Russian Quantum Center and a PhD student of MIPT. And today I will tell you about Python language and Colab space that allows to simulate different things and solve one of our problems. Okay, so let's start our introduction to Python and Colab. And one important detail that if you have any question, please write to our assistants. They really like to obtain questions from you and really glad to answer them. So let's start from basic arithmetic operations, just simple division, multiplication, etc. To get the power of a number, you use two stars. So here 10 to the power of 2 is 100. All the operations are done as in the mathematics. So if you have a sequence of operations, then the laws are just the mathematical laws. So here the division will be first and multiplication is second. And if you want, you can use brackets just in mathematics, and all the laws are the same. So firstly the bracket will be, then the multiplication, and then the summation. Also, in Python, you can use lists or arrays. Those are just some pieces of data, which you can use. For example, you can create an array. Here it is called A. So you define some variable A, which is array. You use square brackets to define it and commas, and it means that here you have some A with elements 1, 2, 3, 4. And to see the variable, the value of the variable, you just can print the variable here, and you see the value of it. Then, to go to one of the elements of the array, you can use indices. For example, A of 0, the indexation starts from 0 in Python. So A0 would be the first element of the array, A1 would be the second, and you can change the values of the elements of the array. For example, A1 equals 12 gives you just the change of the first element. Let's check. Now I print A, and you see that the second element is not 2, but is 12 that you gave on the previous step. Then you also can use negative numbers, negative integers as indices. For example, A of -1, minus first index, is the last element of the array. And for example, A of -2 is just not the last, but the previous element of the array. Let's check. A of -1 is 4, A of -2 is 3. Okay, you also can add elements to the array. To do this, you use append function. For example, here I add the number 5 to the array. So you see that our array changes and the 5 is added. Okay, then some bool type variables can be used. Here A is true, B is false, C is 5. Okay, and you can also print different conditions. For example, if I print A equal B, it's false because A is true, B is false, and you see that they are not equal. If I print C is larger than 5, you see that it's also not true because C is equal to 5. If C is less than 7, it's true, so I will see true. And if C is not equal to 9, it's also true. And then if I print this condition, I will also see the true. Let's do this steps. Okay, also I can do some logical operations, for example, AND, OR, etc., and you can check that it works. Also, I can use if and else to check some conditions. Here is just, the code is just works as follows. If C is larger than 6, you remember this, that our C now is 5. Then if C is larger than 6, please print C is big. Else please print C is small. That's what this code means. And you remember that C is 5, so it checks that C is not larger than 6 and goes to the else. Else works, so it prints as small, C small. Let's check. Okay. And if I now redefine the C variable as C equal 100, then the first condition works, C larger than 6, and it prints me C is big. Let's check. You see, C is big. And also loops exist in Python language and other programming languages. For I in some range, here range 10 means numbers from 0 to 9, I just ask him to print I. So it goes through this range and print the variable. Of course, I can change print to some mathematical operation or some definition of other variables, etc. It's natural. Then for E in, also I can define E not in some range, but in just some elements as some elements of an array. For example, here for E in this array is defined and E runs to the elements of this array. And let's do this step. And you see that in this cycle, in this loop, I'll ask Python to print I. So you see that it prints all the values of all the elements of the array. And then I ask him to print 5. And you see that it prints me 5 at the end. But if I change, if I comment this string and this comment, this print 5, you see that the only difference is this space, 4 spaces here. And if I have 4 spaces, then this print is not out of the loop, it's inside the loop. And it means that each time I change the I print this 5. So it means that you will see that 5s are added at each step of this loop. Okay, then I can find the sum of elements in some array. Let's do this. And you see that we have error here. Why do we have an error? Because if you remember, we firstly defined our parameter a as some array, but after that we changed the redefine the variable a as Boolean type, as true. And it means that in Python we can redefine variables, and it means that here, if you have some error, you have this red circle. And because of this fact that our a now is not an array but is a Boolean type variable, we can't use it in this loop. That is why it gives us error. Let's change something just for the code to work. For example, let's redefine once again our a. For example, 5, 4, 5, 3, 1. Okay, so and let's do this step once again. You see that we obtain true result, 4, 5, 3, 1. So for E in this array, please, sum is equal to sum plus I. This is the same as sum is equal to sum plus I. So you see that it changes the variable sum, adds to the sum I, so elements of the array, and it means that at the end, in the sum variable, we will have the sum of all the elements. You can check that it's correct. Okay, then this string means that I create array which is empty, so I don't have any elements in B, but I can append elements in B, as you remember. So in this loop, I just add the elements from the range 10 to array B, and you can see that, yes, indeed, at the end we have this B array. Okay, then not only for loops exist in Python and other languages, but also while loop. It differs from the for with this condition. So instead of going into some range, the variable is checked with some condition. So you see that here the condition is the value variable should be less or equal to the 10,000s. So when our value becomes larger than 10,000s, then the loop while ends. Okay, you can check it. at the next step, we have that 3, 5, 6, 7 goes to the second power, and you see that it becomes larger than 10,000. That is why the while cycle loop ended. Okay, you can also use useful modules. Those are some parts of the language that are written with programmers and that are really useful, and you can use them. To use some module, you should import it. So here we import NumPy module as and b, and for example, this NumPy has the pi number, the pi constant in it. So you can just use the pi constant. Then let's go to the next step, and you see that I have here just simple array that we already mentioned. And for example, I want to square this array, so I want to square each element out of this array. Let's see. You see that we have an error here because Python cannot take the power of an array. It doesn't know what is it. That's because you cannot use operations with arrays, just simple arrays. To go to the second power, we just change our array to NP array. So you see that I just redefine my A with NP array of it. And now let's try, and we will see that I can obtain the second power of A. You see that it just takes the second powers of each element of this array, and even cosine of each element of array, and cosine of 5a plus 2 plus a to the third power. So you see that you can take any function of array if it's NP array. Okay, and you see here that, for example, NP cosine of 3.14, which is just approximation to the pi constant, and cosine of pi, they differ naturally. Here is linspace function. It's really important because it creates an NP-type array with the lowest limit, this number, the highest limit is this number, and the number of elements is defined here. So you see that it creates 10 numbers from -2 pi to 2 pi. Okay, and then it calculates the cosine of this array. Let's check and see what happens. And of course I can change the number of elements. You see that it changes? Okay. And this function is important because it helps us to make plots and graphs of functions. Please remember it. Linspace. Okay, let's go to functions and plotting. You can define your own functions. And to define your function, you use word def. Then you write down the name of your function and the arguments of it. Here we have x, a, and b. And then you write what you want to calculate. Here I calculate ax plus bx. And just return the value that you want to return as a result of your function. And you see that I can use different functions here: cosines, exponents, logarithms, etc., etc., powers. So here is just the simplest. And let's print my function of arguments 1, 2, and 3, and let's see what happens. Yes, you can check that ax plus bx with 1, 2, 3 gives exactly 5. Then also we want to plot graphs because they help to visualize the data, and it helps a lot to understand the physics, for example, of different things, different systems. So to make plots, you just import the matplotlib pyplot library module, and here we also import NumPy. So you create NP arrays x1, x2, y1, y2, and then to plot something you use functions from matplotlib pyplot. You write pyplot plt figure, then you write plot, and here you write this syntax means that you plot y1 of x1. Also, at the same figure, you plot y2 of x2. You can continue and plot y3 of x3, etc., as you wish, as many graphs as you wish. And then I also add here labels, x label and y label of my graph. Let's see what happens. Okay, so here you see just the graph, y label, x label. If you want to specify the limits of x and y, you just write it here. If you want to specify the grid, you write it here. If you want to change the scale, for example, if you want to make a logarithm scale graph, then you add such strings. And you also can change the title of the plot. Let's do this, and you see that it's logarithm plot, and we also added the plot title. Okay, also you will need some optimization routine to solve the problem. Here we import not the full module SciPy optimize, but only one function, curve fit, from it. And this curve fit allows you to take some data, x and y's of your experimental data, for example, and find the best curve that suits your data. For example, if you know that your data should have linear dependence, your y should have linear dependence on x, you want to find the best line that gives you the best fit to your data. For that, you need curve fit function. First of all, you define the function which would be the fit to your data. Here it's sine of ax plus b. And then you can use the curve fit function to find the fit. Here we need just to create some data, and we just add this function with some parameters and some noise. And function curve fit allows to find the parameters a and b of this plot, of this curve, to fit your data. So as an argument of this function, you use your function that you defined, your fit, then x variable, which has your data, and y variable, which has your data. And then you find parameters of the fit. Now we will print them and we'll see if they are close to 0.5 and 8. And also it calculates covariances. Covariation allows to find the error of your fit, but we will not use it here in the problem. But if you're interested, you can search the internet and find the information. Okay, let's do this step and find the parameters. So you see that our parameters is approximately 0.5 and something, not 8, but some number that, as Python says, gives the best plot. Okay, and after that we plot just, we want a smooth curve, so for that we use linspace function. I just create 1000 points from x0 to x minus 1. So I have 1000 points to the x array, to the x-axis. And I just plot two figures. The first figure is scatter xy. It just gives me the points when my data, for my data. So the points are my data points. And then I just plot the fitting function with variable t, for which I used linspace, and my parameters that I calculated. You should add here a star for your parameters to be just two numbers, not an array, because here params is an array of a and b and not two numbers. Okay, then I just plot them, and you see that my fit is really a nice one to my data. Okay, then let's move to the most important part, because this part is needed for the solution of the problem. Okay, first of all, if you start to solve the problem, you need to install the packages. Those packages are not from Python. You here should use lamps package, which is written in C++. That is why each time you want to start a simulation, and each time when you have 90 minutes break before your simulation, you should run this cell and install the packages. It takes approximately 15 minutes to install. So just each time you have 90-minute break, or you want to start the simulation, for the first time you need to install these packages. So you just run this cell. I will not do it because I've already did it. And you start the cell, wait for 15 minutes, and it becomes installed. Okay, and after installation, each time you install, you need to restart the runtime. For this, you go to runtime and restart runtime in the top panel of Google Colab. I here have the Russian version. In Russian it's среда выполнения and перезапустить среду выполнения, but in English you have just as it's written here in the comment. Okay, and then we did this to install the PyLion package. PyLion package allows to simulate the classical dynamics of ions trapped inside a Pole trap. And here I will explain briefly the syntax of this PyLion package, with which you will simulate the coordinates of ions inside the Pole trap. Okay, firstly we start the simulation. Then we create a single calcium ion. Here I specify the mass of the ion and the charge of the ion. Important detail. If you, for example, run the simulation with some type of ion, some mass or some charge, then you want to change the type of ion, you want to change mass or charge, then you will need also to restart runtime once again. So each time you change the ion species, each time you change the type of the ion, you need to restart the runtime. Okay, so here you create the ions, the calcium ion with mass 40 and charge +1, and you add one ion. You can change not one, you can, for example, change and take 10 or 20 ions or 100 ions. But here you create a random cloud of ions inside the box with dimension 1 millimeter. Yes, and you create one ion inside this box. All the coordinates and times are in SI units here, so all the coordinates are in meters and the times are in seconds. Okay, then you specify the parameters of Pole trap. I advise you not to change these parameters because those are just some geometric parameters of Pole trap. And you can change those parameters, which are the frequency of RF field in hertz, the radio frequency voltage, and the DC field voltage here. Okay, then you create the trap with specified parameters, and you add this linear Pole trap into the simulation. Then it's important to save the results, so we add two files, positions.txt. So we add the Pole trap into the simulation with this string. Then we add a Langevin bath. It's some force that allows to cool ions. So we add this Langevin bath for cooling or heating ions if you want to heat ions. So it has two parameters. The first is the temperature to which you want to cool or heat ions, and here is the constant which gives the speed of this cooling or heating process. Okay, then you want to save the results. For this you add two files, positions.txt and secular velocities.txt, which allows to save the results as coordinates x, y, and z of ions, and some averaged velocities Vx, Vy, and Vz, which are averaged over this radio frequency. Okay, and then you write evolve function, which gives you the number of time steps for which you want to perform your simulation. So here I just want my simulation to last 100,000 steps. For sure I can change, for example, million or etc. 1 if 5 means that 1 multiplied by 10 to the power of 5, so 100. Okay, 100,000. Okay, after that I read the data. Coordinates of ions here, you can add the same to read the velocities of ions. And here, x, y, and z are just the arrays that contain, for here, 100,000 values. So at each point of time, you have coordinate x, coordinate y, and coordinates z that are saved in those variables. Okay, so here, after that, are the functions to calculate the spectrum of ions. You will not need it in the problem. You will need only the values, so you can just use this code. For interested people, it's just the fast Fourier transform of coordinates x, y, and z. After that, you plot the results. Here, we plotted the simulation, the coordinates over time. And you see that the coordinates are multiplied by 1 million, because usually in Paul traps, the coordinates of ions are micrometers and the times are microseconds. Yes, and we also plotted the frequencies. And we printed the secular frequencies of x, of y, and of z. Sorry for Russian language, I will translate it for your version. It will be in English. Okay, and you see that we have some graphs here. Sorry, I don't see the graphs. Okay, I see the graphs. And you see that we have something strange here for coordinates x and y. We have 10 to the power of 306. It's strange, and I will explain you why. Because we have such parameters here that do not allow to trap the ion. So such big coordinates mean that we didn't trap the ion. And that is why the oscillations and the coordinates are just too large. So in your problems, you will need to find such parameters that will allow you to trap the ion. Okay, that's it for our problem. Let me remember what I should say you also. Please, when you send your solutions to us, send not only the IPyNB file with your solution, but also please save this file as PDF. For example, here I have Yandex browser. I need to print it, and you see that I will have save as PDF. And you then just save the PDF file and also send it with your solution. In Google Chrome, you also have 3 points. Just print, and you will also be able to save it as PDF. So send us, please, both IPyNB file and PDF file. Okay, that's it for the problem. I wish you luck and see you.